Welcome to this last video in our unit on measurement. Today we'll be looking at the volume of rectangular prisms. We'll be looking at what the volume of a three-dimensional shape actually is. We'll look at the common metrics for volume, including millimeters, cubic centimeters, cubic meters, and cubic kilometers. We will look at what a rectangular prism is, and we'll know this also by the name of a cuboid. And we'll also be able to find the volume of a cube and other rectangular prisms. And again, as usual, success criteria, is when we can do each of those things. So let's have a look at our key ideas. As with area, we first have to think about what the unit of measurement will be. So they're very similar, except for instead of talking about in the sense of a squared amount, we're talking about in a cubed amount. So we have a cubic millimeter, a cubic centimeter, a cubic meter, and a cubic kilometer. When you think about it, a 2D shape like we were doing earlier where we had area, it was a flat piece of, a flat space. So that's why it was squared, because we had two measurements involved. But here we have a three-dimensional shape, so we are talking about a cubic or to the power of 3. And we can see that with our measurements here. So we have 1 mm cubed, or the 3 up in the top right corner there, 1 centimeter cubed, 1 meter cubed, and 1 kilometer cubed. The volume of the rectangular prism is given by the length multiplied by the width multiplied by the height. So again, we're taking 3 measurements into account, which helps us to understand why we talked about something being cubed. And a rectangular prism is always going to have a rectangular shape, so it's the length multiplied by the width multiplied by the height. So we can write that as V for volume equals L times W times H, L for length, W for width, and H for height. Or again, we start to see algebraic forms where we just remove the multiplication symbol and we can say V is equal to LWH, which is the same as saying length times width times height. Now, a rectangular prism can also be called a cuboid. So you might see that term being used in different places, but when we talk about a cuboid, we are talking about a three-dimensional rectangular prism. The volume of a cube, just like the area of a square, but the volume of a cube being a special one where all sides are equal still, can be given by the length multiplied by the width times the height. We could still do that, but because it is a square, or in this case a cube, so all sides being the same, we can just talk about the length being to the power of 3, the same as length times length times length, because all of those sides would be the same. So again, just think of it like a square where we did area. Because both sides were the same, we could just say length squared. But now, because we're doing into the third dimension, we can talk about the length being cubed. So length times length times length. So let's have a look at an example. Here we have a rectangular prism. So we could say the volume of this rectangular prism is equal to the length multiplied by the width multiplied by the height. So we usually talk about this one here being the length, the 8 centimeters. The width would probably be this 3 centimeters here, and we'd usually talk about the height being this 4 centimeter measurement. So we put those numbers into our formula. We have 8 multiplied by 3 multiplied by 4. And as always, we should just do one step at a time. So let's do 8 times 3 is equal to 24, still multiplied by 4. And then we have 24 times 4 is 96. So we would have 96. It is centimeters, because that's a unit of measurement. And because we're talking about volume, it is cubed to the power of 3. So a simple rectangular prism there. Also known as a cuboid, remember. And it's length times width times height. And we just have to plug in the numbers. So let's now have a look at the types of questions you're going to be asked. The first question simply says to find the volume of these rectangular prisms. So again, it's really about understanding what the measurements are, plugging them into your formula, and off you go. So the volume is equal to length times width times height. I always recommend you write the whole formula out just to help you to practice remembering it. So in this case, let's say this is the length, this is the width, and this is the height.
Again, it's a good idea to label them on your diagram if they're not already labeled. So we're going to have 8 times 3 times 8. So let's do the math. So 8 times 3 is 24. That's still by 8. And that is equal to 192. Again, centimeters is the unit of measurement, and it is cubed. Don't forget the cubed. In our second example here, we have another rectangular prism, but we can see by the fact that we've got these markings on here for the 3 sides that this must in fact be a square rectangular prism. So all those sides are going to be the same. So we could go through and say length times width times height, and we could still do it that way, but we can also say in this case volume is equal to length cubed. All right. Remember, that is the same as saying length times length times length, right? Length cubed. And we've got one length here, so we can say 2.5 cubed, and that is going to be equal to 15.625, excuse me, and that is millimeters. And of course, don't forget the cubed here. Question 3. It's a worded problem, so the first thing I'll be looking for is keywords or numbers that help me to understand what the question wants me to do. And I'm also going to be thinking about drawing a diagram to help me to understand what shape I'm dealing with. So it says a fruit box is 30 centimeters long by 40 centimeters wide and 15 centimeters high. Find its volume. Well, this one's really quite clear because it actually tells me its length is equal to 30 centimeters, its width is equal to 40 centimeters, and its height is equal to 15 centimeters. So I don't really need to draw a diagram here because it's literally told me what each of those values that I need are, but I don't think it's a bad idea. So if we were to draw this, our width is going to be something. It's going to be something like this. We're going to have a rectangular prism, and you don't have to draw a perfect rectangular prism, just enough to get the idea. So we're going to say the width is equal to 40 centimeters. We're going to say the length is equal to 30 centimeters. And we're going to say the height, put over this side, is equal to 15 centimeters. So there is a diagram of what the question has asked me to do. But again, I could have just plugged these straight in. So let's have a go. Volume equals length times width times height, which is equal to 30 times 40 times 15. 30 times 40 equals 1,200, still multiplied by 15. And then we can do that math. Again, I'm just going to use my calculator now to save a bit of time. That comes to be 18,000. Okay, remembering that the unit is centimeters and not to forget the cubed. So this particular box has an 18,000 centimeter cubed volume. Question 4. Again, it's another worded problem. So a shipping container is 2 meters wide, 3 meters high, and 8 meters long. Again, it asks us to find the volume. So just like the previous question, technically all our values have been given to us. So we have a container that has a width or W of 2 meters. We have a H or height of 3 meters, and we have a length or L of 8 meters. So we could go and plug those straight into our formula and work it out. But again, I think it's a good idea to draw a diagram. So just because I know shipping containers are kind of longer than they are wide, I'm going to draw more of this sort of rectangular prism this time. Okay. And I've got a width of 2 meters. I've got a length of 8 meters, and I've got a height of 3 meters. Okay, it just helps me to visualize this particular problem. But let's go ahead and plug it in. So volume equals length times width times height, which is equal to 8 times 2 times 3. 8 times 2 is 16, still times 3, and 16 times 3 is 30, 48. Now don't forget the M for meters, and don't forget the cubed as well. So this shipping container has a 48 meter cubed volume.
Now, one thing I did forget from the previous question is this is a worded question, so it really should have a worded answer. So let's make sure we do it properly this time. So the container has a volume of 48 meters cubed. So very important that we do always finish a worded question with a worded answer. Question 5, again, another worded question. A short rectangular ruler is 300 millimeters long, 30 millimeters wide and 2 millimeters thick. Find its volume. So again, all our measurements have already been given to us. Our length is equal to 300 millimeters. Our width is equal to 30 millimeters. And our height is equal to 2 millimeters. So we can go and straight away do the equation, but as always, I like to draw a diagram. Now, it's talked about a ruler, and I know rulers are very thin, so I'm going to do a very long rectangular prism like that. So my height is only 2 millimeters. That's the height. All right. The width is 30 millimeters. So that's this measurement across here. And our length in this case is going to be 300 millimeters. Okay, that's that long measurement there. So that's our ruler. But again, let's plug in our values. Volume equals length times width times height, which is equal to 300 multiplied by 30 multiplied by 2. 300 by 30 is 9,000, still times 2. And then we have 9,000 times 2 is 18,000. Again, millimeters. And don't forget the cubed. So that ruler has a volume, an internal measurement of 18,000 millimeters cubed. Now this is a worded question. So again, we need a worded answer. So the ruler's volume is 18,000 millimeters cubed. Simple as that. Question 6 says, there is enough ice on Earth to fill a cube of side length 3,000 meters. Find the approximate volume of ice on Earth. So it's another worded question that's given us some information. First of all, we know it's a cube. Right, so remember that's one of those special types of rectangular prisms where all the sides are the same, and therefore it's given us one side length of 3,000 meters. So again, it's a good idea to draw a diagram. So I'm trying to draw roughly something that looks a bit like a square. Not the best work ever, but again, I'm going to indicate it is a square by putting those markings on. And by at least putting those markings on, I'm telling us that this is a cube, because it's got a square front face and the distance in the length is also a square. We just label one of these, so the one side that it's told us is 3,000 meters. Okay, so now if we do our volume, we can say volume, because this is a cube, we can say volume is equal to length cubed. Okay, remember that is equal to length times length times length if you don't know how to do cubed on your calculator, for example. So really that's the same as saying 3,000 cubed, or 3,000 times 3,000 times 3,000. We should remember that from earlier on. So if we know how to do cubed on our calculator, 3,000 cubed is a very big number. It is 27,000,000,000,000. Okay, so that's 27 billion meters is our measurement, and don't forget cubed. So if this question is correct, we're saying that there's approximately 27 billion cubic meters of ice on Earth. Pretty big number. Now, question 7. These solids are made up of more than one rectangular prism. Use the addition or subtraction methods to find the volume of the composite solid. So this is taking into account the ideas we've just learned about volume, and also what we've previously learned about the ideas of composite shapes, and we need to use both of those skills together to try and solve this. So if we have a look at this diagram, we want to look at how we might be able to cut this up into simpler rectangular prisms that we can work out. So my suggestion is that we cut across these things that look a bit like legs. So we basically cut those off. All right, so I'm trying to do both sides here, of course. So we end up with these two legs sticking off. Now the reason I suggest we do that is we've got this 4 centimeter measurement in the middle there, which tells us that this one side of this rectangle is 4 centimeters. We also have this 9 centimeter measurement over here, which tells us this whole length is 9 centimeters. So if the first part is 4, then up to this dotted line we've added in, then these legs must be 5 centimeters long. Okay, so these legs are 5 centimeters. I'm going to write it over here. Okay, so that length there is 5 centimeters. And that would be the same for this length here. This would be 5 centimeters. Okay, and so on. So that's one measurement. The other measurements we already have. We have this 2 centimeters at the front here, so we know how wide these little legs are. And that also tells us that the height of the whole shape is 2 because it's got these lines on it, these indicating lines that they are the same. Okay, so what we've really ended up with, and I'll just sort of draw it, I guess, on the side here. So we've ended up with a rectangular prism that looks a bit like this. So this sort of flat one. Okay, so that represents this top section, and that is going to have a length of, what is it? Lost it. 8 centimeters, sorry, because that's told to us at the bottom. It's going to have a width of, was it 4 centimeters we said, because that was the amount up the top here. And then it's going to have a height, because it's all the same, of 2 centimeters. So that's the first shape. We've then got another shape like this that has a square front, but it's long. So this is one of the legs. It's going to have a 2 centimeters, 2 centimeters, and we worked out that the length of this one, the width, we're going to say, is going to be 5 centimeters. So that's all there. But we've also got 2 of these. So if we just say we've got 2 of that particular shape, all right? So what we're going to do, just like with composite area, we're going to work out the volume of each of these, and then we're going to add them all together in this case. Okay, so that's one way. Another way that you might have done it is if you can work out what the cutout shape is, you can work this cutout area, you can work out the whole big shape and then take that out. That's also completely valid. All right, I'm going to do it the other way. So I'm just going to clear some of this mess up, and then we'll go ahead and work out these areas. Oh, sorry, these volumes, I should say. Okay, so I'm going to call this R1. I'm going to call this R2. Okay, the reason I'm doing that is I want to write a little formula that works out the whole volume. So I'm going to say the volume of the shape, or the volume of T for total, is equal to volume of R1 plus the volume of R2 plus the volume of R2 again, because I want 2 of this leg and 1 of the body. Another way to write that would be volume of R1 plus 2 times volume of R2, because we've got 2 of them. Okay, so that would be another way I could write that. If we go ahead and work out what these are, so the volume of R1 is equal to length times width times height, don't forget, which is equal to 8 times 4 times 2, which is equal to 32 times 2, which is equal to 64. Remembering this is centimeters and cubed. The volume of R2, so the little leg, again, is equal to length times width times height, which is equal to 2 times 5 times 2, which is equal to 10 times 2, which is equal to 20 centimeters cubed. So we worked out what the volume of each of these components is. Now let's take those numbers back to our overall formula. So where we had VR1 for the volume of rectangle 1, we're now going to say it's equal to 64 plus, and again we can either do plus the 20 centimeters for VR2 twice, or we could just do it into the multiplication. I'm going to do it into the multiplication. So it's 2 times 20. course, we'll work out that bracket first. So it's 64 plus 40. So 2 times 20 is 40. And then 64 plus 40 is of course 104. And don't forget centimeters and cubed for the units. So again, this is a composite shape. It did say that up in the instructions, so hopefully you picked up on that. And I decided to cut these little leg pieces off and do it that way. But of course, you could have done one big shape and worked out the square in the middle and then taken that away from the big shape. Both of those would have been perfectly fine. Question 9. The outside dimensions of a closed wooden box are 15 centimeters by 15 centimeters by 15 centimeters. If the box is made of wood that is 1 centimeter thick, find the volume of air inside the box. So at first glance, this seems pretty straightforward. Okay, we have a box that is going to be a square rectangular prism, which kind of sounds a bit funny. We know it's the square one because they're all 15 centimeters. So it's going to be 15 by 15 by 15. So all these sides are the same. So we could go ahead and find the volume of that box. Okay, but we have to think carefully about this question, because it then says that the box is made from wood that is 1 centimeter thick, and we're trying to find the area of the volume inside. So we have to think about this for a second. If you draw pictures like we've been doing here with a pen, we're really talking about them not having any thickness. It's just a line. But we're now talking about a piece of wood that has a thickness. So that's joined onto another piece of wood, which is joined onto another piece of wood going this way. So we lose some thickness for each one. It's a little bit tricky to draw because we basically need to draw another square inside of this square that will have different measurements. So we'd actually be drawing a smaller square inside this square, which again gets very tricky to draw, and everything would be 1 centimeter less. So the distance from there to there would be 1 centimeter, and this one here would be 1 centimeter, and the same on the top, but also in this distance. So everything starts to get smaller. So the easiest way I would think about this is to look at one side first. So if I just draw the front of this box, all right, that is the outside measurement, and that is 15 by 15 by 15 by 15. Okay. Now, if I think about the thickness of the wood, I'm going to draw another box inside, and each one of these measurements here is 1 centimeter. All right, to think about the wood. Okay. And then we need to take that into account. So if we look at the distance, so the total distance across from there to there was 15, but we're also losing a centimetre on each side. Really, these inside measurements here would be 15 minus 1 minus 1, minusing 1 from each side. So that would, of course, be 13 centimetres. Okay? Now, because we know it's a square, if we've worked out one of these sides is 13, then all of these sides must be 13. So really, I guess what we're ending up with is that we're going to take 2 centimetres off every one of these measurements that we've been given. So we actually end up with the inside box having measurements of 13, 13, and 13. Now we can go ahead and just do our volume equation. So volume equals the length cubed, because it is a square a square rectangular prism, all right, which is a silly term. So that's going to be 13 cubed, which again, remember, that's 13 times 13 times 13. If we put that into our calculator, we get 2197. Okay, don't forget that is centimetres, and cubed needs to be added. So the volume of the inside of the box, which in this case is being made up of air, as it says in the question, is 2,197 centimetres cubed. This is a very common sort of question actually when you start building things, because we often talk about the outside measurement of something, but then we often want to put something into a box, for example. So you might say, yep, I've got enough space because my box is 15 by 15 by 15. and I can put this piece of whatever in, but then you don't actually have enough room inside because you've forgotten to take into account the thickness of the material that you are using. It's really about understanding that we had to take off a centimetre on either side of this measurement. And that is it for today. So again, as always, rewatch these if you need to, and if you really get stuck, please get in contact. And as I said at the beginning, this is the last video in this particular measurement unit. So the next thing we'll be doing is some revision. So I encourage you to go back over all the videos that you may have watched for this topic, go back over your notes and any set revision tasks in preparation for the unit test.